Hello everyone. Today we will discuss on pharmacokinetic parameters. Pharmacokinetic, it is a study of movement of drug into, around and out of the body. That is, it is study of ADME, absorption, distribution, metabolism and elimination processes. Various stages involved in pharmacokinetic study, that is dosing, collection of sample, that is either urine sample or blood sample, analysis of drug and metabolite in the collected sample, and analysis of collected data. This pharmacokinetic data can be analyzed by using any one method, that is either model based analysis or model independent analysis. Either we can go for physiological model or the compartmental analysis, or we can use the model independent statistical methods. Then why we study this pharmacokinetic data? Main important reason is to determine various pharmacokinetic parameters: clearance, volume of distribution, half-life and rate constants. Clearance is one of the important parameter, can be defined. It is a volume of plasma or blood which is completely cleared off from the drug per unit time. So drug is removed from that particular blood or from the plasma, and it is a volume of plasma which get cleared off, means drug is removed from that volume, that is called as clearance. And volume per unit time, such as liter per hour or ml per minute, are used to express clearance of it. Then volume of distribution, it is also called as apparent volume of distribution. It is a hypothetical volume of body fluid that relates to plasma drug concentration to the amount of drug in the body, or it is a ratio of plasma drug concentration to the amount of drug present in the body, and it is expressed as liter or ml. Half-life or biological half-life, generally we use term, it is a time required to decrease plasma drug concentration to half of its initial concentration, that we called as half-life. It is denoted in an hour, minutes or in a day. Now a reflection point: what are the clinical significance of these pharmacokinetic parameters? Pause this video, write your answer and again play to listen further. Clearance, as we said, it is a volume of plasma or body which get completely cleared off, and it is very much essential to determine the maintenance dose during multi-dose therapy. Maintenance dose is given to maintain the steady state plasma drug concentration after loading dose. So this maintenance dose can be determined by using formula MD is equal to CSS into clearance, where CSS, that is steady state plasma drug concentration, and clearance of a drug. Second one, volume of distribution. As we say, it is a hypothetical volume that relates the plasma drug concentration and amount of drug in the body, and it helps to determine the loading dose of a drug. During multi-dose therapy, when drug is given, that time initially plasma drug concentration is below subtherapeutic range, and if we are giving the constant dose, then after some period of time we can achieve the therapeutic window, but it is time consuming. So loading dose means initially one booster dose is given so that immediately plasma drug concentration reaches to the therapeutic range. And by using volume of distribution, the loading dose can be calculated by using formula loading dose is equal to CSS into volume of distribution. One more important clinical significance is that if the value of volume of distribution is more, then it shows extensive drug distribution and higher dose is required. And in case if volume of distribution is less, then lower dose is required. The next parameter, that is time required to decrease plasma drug concentration half of its initial concentration, means to reduce the plasma drug concentration time period is required, means reduce plasma drug concentration to its half concentration, the time period is required, that we call as half-life, and it helps to determine the time to reach steady state plasma drug concentration. Generally 3 biological half-lives are required during continuous dosing, and dosing interval means how much period of time we can give the, we have to give the next dose, that we can determine by using biological half-life. Collectively we can say this volume of distribution, clearance and half-life are used to design or tailor a dosage regimen. These are the references for further assessment or further study. Thank you.